experience and NASA's interest in my concept of rendezvous in space influenced them to accept me in the third group of astronauts, where I became known by my astronaut peers as Dr. Rendezvous. We had 7 people in the first group, 9 in the second group, and 14 in the third group. An engineer, a very clever engineer named John Houbolt, figured out that if we used 2 specialized spacecraft at the moon, a command and service module to remain in orbit around the moon, and an ascent and descent stage of the lunar module to land and later rendezvous in Earth orbit with the command and service module. By doing that, the lander's rocket motor didn't have to be so big, and we could leave the descent stage on the surface and the ascent stage in lunar orbit. And this is where my MIT rendezvous studies really paid off. The critical key to this approach would be our ability to reliably rendezvous 2 spacecraft in orbit around the moon. A rather dangerous maneuver, for if it failed, there'd be no way to be rescued by the 1 person in orbit to bring the 2 of us back again. Luckily, of course, my MIT work was exactly what was needed. During my first space flight as pilot, NASA doesn't like the term co-pilot. There's a commander and a pilot. I was a pilot on Gemini 12. A lot of people call it Gemini. Engineers call it Gemini. I was able to set a 5.5-hour world record while spacewalk while circling the globe every 90 minutes. We're traveling at a speed of 17,000 miles an hour. What a sight to behold the Earth below while floating outside the capsule. After 5 days in orbit, Jim Lovell and I returned to Earth, having completed the final mission in the Gemini program. It was November 1966, and we had only 3 years left to accomplish Kennedy's challenge to land a man on the moon by the end of the decade. Gemini had prepared us for the Apollo missions to the moon, but we still had a lot of work to do. And there was the Apollo fire in January of 1967. In all, there was a team of 400,000 people working together on a common dream. The engineers and technicians who were designing and building the multi-stage Saturn V rocket, the rocket scientists, aerospace industry contractors, NASA administrators, even the seamstress who sewed our spacesuits. It took a unified effort to accomplish everything that was needed. At last, we reached the day when the Saturn V rocket was first rolled out from the vehicle assembly building on its way to the launch pad. The timing of the crew rotations was just right for Neil Armstrong, Mike Collins, and me to be chosen as the crew for this historic mission. So on July 16, 1969, our launch day finally arrived. We took the elevator up the gantry where the 360-foot tall Saturn V rocket stood magnificently as the countdown progressed. Due to the seating order, Neil on the left, Mike on the right, and I was in the center, I was the last one to board the command module. So while Neil and Mike took the elevator up to the top, the end of the spacecraft, I stood 2 flights down alone with my air conditioning on the gantry. I could see the sunrise over the waves of Cocoa Beach, and I thought back how wonderful my life had been up to this point, and the many things that had worked out along the way to put me in just the right place at the right time. At 9:32 a.m., the engines ignited and roared with over 7 million pounds of thrust to lift 3,000 tons of spacecraft, fuel, equipment, and 3 astronauts. As we cleared the gantry and rocketed skyward, we were pressed into our seats as the acceleration of the rocket gradually increased our body weight. Within 3 minutes, we were 45 miles high, now experiencing 3.5 Gs and traveling at nearly 6,500 miles an hour. A minute later, we passed the 62-mile boundary, 100 kilometers, French defined where space begins. Where the blue sky really turns into the blackness of space. By 12 minutes after launch, we were traveling at over 17,000 miles an hour, the speed required for us to stay in orbit of the Earth. For 3 hours, we twice orbited our home as we ran through the checklists and assured everything was working. Then we fired the engine that accelerated us to 25,000 miles an hour on the trajectory bound for the moon. On the total 8-day round-trip journey, the three of us lived in space capsules about the size of a standard automobile interior. On day 3, we fired our engine to slow us down enough for the moon's gravity to capture us and put us into lunar orbit. Another tricky engine burn put us in the right orbit for the landing. We'd estimated about 60% chance of being able to land successfully, but we could abort at lots of points, and we felt we had a 95% chance of returning home safely. And I guess we're satisfied with that. 13 orbits of the moon later, on the morning of Sunday, July 20th, Neil and I entered the lunar landing craft we had named Eagle and separated from the command module, Columbia, where Mike Collins remained. Piloting our powered descent to the moon's Sea of Tranquility was the most complicated and critical aspect of the entire mission. As we descended, we saw that our landing site had a few boulders in it, such that we continued maneuvering to find a safe area. But this expended additional fuel, and so when we landed, we had 15 seconds of fuel left. As we touched down, Neil spoke the words, "Houston, Tranquility Base here. The Eagle has landed." There's been much discussion over the last 40 years about why Neil was the first to step on the surface. It could be because he was the mission commander, and in our armed services, the leaders are always at the front of their men. It could also be because he was closer to the door. I'll never tell you which one it was. With Neil on the surface and snapping a few photos of me, I carefully backed down the ladder and partially closed the hatch, being careful not to lock it on my way out. As I stepped onto the talcum-like lunar dust, the first words that came to my mind were magnificent desolation. It was a magnificent accomplishment for man to set foot on another world for the first time. And yet there was the desolation of the million-year-old lunar landscape with no sign of life, no atmosphere, just total blackness beyond the sunlit terrain. We spent about a total of 2.5 hours on the surface, collecting rocks, setting up experiments, and taking numerous photos. In this experiment, we were supposed to not walk in front and cast a shadow on the solar collectors. But if you look and see those footprints on the right, that's what we call condemning evidence.